So here's a problem using confidence intervals. So we are interested in finding if the human population believe in life on other planets. So we sampled 100 people and found that 60% believe in life on other planets. Okay. So part A says use this data to find a 99% confidence interval estimate for the true proportion and round to 3 decimal places. So the key word here to kind of just know is confidence interval. Okay, so if the problem says confidence interval estimate for the true proportion, well, we're doing proportions and we need to find the formula for the confidence interval. So luckily we already know what the formula is in the previous problem. Here is basically the formula. Okay, this guy. So what I like to do first is that I like to write down the formula with the p hat minus z star square root of p hat 1 minus p hat over n. And then I'm going to do the same thing, but now it's going to be p hat plus z star square root of p hat 1 minus p hat over n. Okay, so now all we really got to do is just plug everything in there. But first, let's try to figure out what exactly are all of these numbers. So are all these variables. So first, let's figure out what p hat is. So p hat is basically the sample proportion. So the proportion of people who believe in life on other planets. So this is already given to you. Is 60%. Okay, so that's just going to be a 0.6. Okay, so that's just p hat. Okay, so p hat can be given to you as a percent, or you might have to calculate it as a fraction, but luckily it was already given to us right there. So p hat. Now we need to figure out what n is. Well, n in this case is 100. Notice that they're sampled 100 people, so n is equal to 100. And then the last thing that we got to figure out is what z star is. The way that we figure out z star is we look at the question about the confidence level. The confidence level in this case is 99%. So if we go back to our table, 99% corresponds with a z star of 2.575. So this is going to be 2.575. So what we're going to do is that we're going to plug in all of these values into my calculator. So let's first start off by plugging into the formula. So we're going to have 0.6 minus z star, in this case is 2.575. Then square root of 0.6, 1 minus 0.6 divided by n, which is 100. Now, I think the hardest part about doing this problem is putting everything into the calculator correctly. So try your best to put parentheses around things that need to have parentheses, because I think this is probably where a lot of students tend to be confused or might get the wrong answer. So what I got for my first one was just, since we want 3 decimal places, was just 0.474. That's what I got for that guy. So hopefully that is correct. And now we're going to do the same thing. We're going to plug the same numbers, but now this guy is going to be plus 2.575 square root of 0.6, 1 minus 0.6 divided by 100. So let's figure out what that guy is going to be. So let's put that into our calculator. But now everything is going to be now with a plus. I'm going to change that to a plus. And I ended up getting 0.726. Okay. So these are my 2 numbers. The way that you want to write them is in kind of increasing order as an interval. So this is between 0.474 and 0.726. Okay, that's my confidence interval estimate. Some students can kind of like seeing it in percentages. You can leave it like this. You can also write it like this if you want to multiply it by 100. It's 47.4%. And then 72.6%. Okay, so I would prefer this because we're talking about proportions, not percentages. But if you want to see it as a percent, this is basically what it kind of looks like. Okay, now part B is interpret this interval. So what the heck did we just calculate? What exactly is this? So this is basically what you want to be able to write. So how confident are we? Well, we are 99% confident about what? So this is what we're going to write. We are 99% confident of what? That the true proportion of humans who believe in life in other planets lies between what? Well, it lies between 0.474 and 0.726. That's basically what it is. Okay, so we are 99% confident that the true proportion of humans who believe in life in other planets lie between these two numbers. Okay, so here are the two numbers that these two lie on. If you want to think about it in terms of percentages, the true value lies between 47.4% and 72.6%, and we can be 99% confident of that particular fact. Okay. So that's kind of like what you want to be able to do when you interpret this thing. So we are 99% confident or 95% confident that the true whatever lies between what and what. Okay, so this is basically how you want to be able to do this problem. Okay, so we want to make sure that we understand what this guy is. Okay, now let's do this last problem. So a sample of 500 nursing applications included 60 men. So find a 95% confidence interval estimate for the true proportion of men who applied for the nursing program, interpret your interval, and round to 3 decimal places. Okay, so let's go ahead and start. So we want to do the confidence interval estimate for the true proportion of men who applied for this nursing program. So let's first start off by writing down the formula. So we know that is p hat minus z star square root of p hat 1 minus p hat divided by n. And then we're going to do p hat plus z star square root of p hat 1 minus p hat divided by n. Okay, so let's figure out what each of our values are in this case. So p hat is basically the proportion. Notice that in the previous problem, they gave us the percentages, but they didn't give it to us in this case. In the previous problem, they told us that it was 60% of them believe in that. So in this case, we don't know what the percentage is, okay? But we know that 60 out of the 500 applied. So we already know what that is. 60 out of 100, 500. That's my proportion. If you want to leave it in terms of a decimal, 60 divided by 500 is just going to be 0.12. So that's my p hat. My n value is going to be 500. Okay. And my z star value, well, that corresponds with the confidence level. We are 95% confident. So 95% confident, if I go back up to my table, is just going to be for 95% is going to be 1.96. So z star is going to be equal to 1.96. So now let's plug in all that into our formula. So 0.12 minus 1.96 square root 0.12, 1 minus 0.12 divided by 500. Okay, so let's put that into my calculator. So 0.12 minus 1.96 square root of 0.12, 1 minus 0.12 divided by 500. I ended up getting 0.09, okay, for that one. 1.092. And then I want to plug the same thing, but now we're going to change the minus to a plus. 1.96 square root 0.12, 1 minus 0.12 divided by 500. So I'm going to do exactly the same thing. Change that minus that we had between the 0.12 and the 1.96 into a plus. Whoops, I did that wrong. Let me go ahead and I'm doing it in the calculator right now too. So I'm going to change that to a plus, and I ended up getting 0.148. Okay, so my confidence interval is going to be 0.092 and 0.148. Or you can do 9% and 14%. Okay, now we're not done. We found our confidence interval, so that's good. We're did that. Now we're going to have to interpret our interval. Okay, so what do we say? So how confident are we? We are 95% confident of what? That the true proportion of what? Proportion of what? What are the proportion of men who apply to the nursing program, of men who applied to the nursing program lies between, oops, that's not how you spell between, lies between 0.092 and 0.148. Okay? So alternatively, if you want to think about it in terms of percentages, the true proportion is somewhere between 9.2% and 14.8%. So if you want to think about it like that, you can also think about it in terms of percentages. So somewhere between this is a true percentage of men who apply for this nursing program, which is a little low, but we are 95% confident. It's somewhere in there. We don't know what it is, but here is how confident we are. Okay.